Alright, this is going to be the 11.4 video by Jared Caston and Danny Banky. Alright, this one's going to be fast and furious, unlike the last one. This one I know is. Alright, so we have equilateral triangle, so that we just use the equation 1/4 r squared square root of 3. So we just plug it in, so it's going to be 1/4 uh, 5 square root of 3, so that's going to be 25 over 4 times square root of 3, and has an approximate value of 10.825. Alright, for the next one, so we gotta find the area and perimeter of a regular polygon. So we're gonna divide or whatever, like if you don't find out the angle measure, and then, oh wait, so I just point, anyways, she's pointing and stuff. Anyways, so like for the last one, we, okay, she needs to change because she has a 3 for the square root or square thing. Anyways, so I'll just try to explain number 2. For number 2, so we're gonna divide 360 by 8, I think, and then divide that by 2 to find out what those little degrees are. So that way, then we can just use the uh, what is it? Oh yeah, trigonometry to figure it. So then a is going to equal 12 cosine 22, and x is going to be 12 sine 22.5. So that's how we get that. And then the one side is going to equal double that of double x, so it's going to be 24 sine 22.5, and then p is just going to be 8 times that, which is 192 sine 225. So then the area is just going to be 1/2 times the perimeter times a, so we just plug those values in. So that's going to be 1/2 12 cosine 22.5, and then 192 sine 22.5. So then we get that all in there, and then then the area is going to have an approximate value about of 407.29, and the perimeter is going to be, once we plug the 192 sine 22.5, we get 73.47. So that's how you do number 2. I think we get there soon enough. I don't know. We just had to get this done because we're really late. But so we're gonna write things out of order and stuff. But that's how you do that one. All right. So I'm gonna move on to number 3. Well, she's still writing for number 2. For number 3, so we gotta find the area of the perimeter again. So we do the same thing. We're just gonna divide, and we're gonna use the trigonometry to solve everything, and we find out that like the inside degree, so I take 360 divided by 5 divided by 2, it's going to get you 36. And so then you're going to solve. It's going to be a is going to equal 7 cosine 36, x is going to be 7 sine 36. Side 1 is going to be once again double x, so it's going to be 14 sine 36. The perimeter is going to be 5 times the 14, which would be 70 sine 36. The area is just going to be half of a times the perimeter, so it's going to be 1/2 7 cosine 36, 70 sine 36. So then we're going to plug those values in, and we're going to get approximately, so the area is going to be approximately 116.504, and the perimeter is going to be 41.144. So that's how that one works. So yeah, and I think I might wait a little bit. Just gonna let her catch up a little bit. I think she just write like 2 more things, and then she's gonna write down the answers. So, yep. So then the next one, once again, is gonna be the octagon. And since for number 4, it's gonna be find the area and perimeter of the octagon or whatever. And once again, from number 2, we know that the inside angle is gonna be 22.5. So let me just do that. But then it gives us the apothem in number 4. So that's nice, because then we know the apothem is 9, and then we're just gonna use trigonometry to find x. So it's gonna be 9 I know it looks like an a, but it's 9 tangent 22.5. Inside it's just gonna be double that, so it's gonna be 18 tangent 22.5, and the perimeter is gonna be 8 times that, which would be 144 tangent 22.5. So then the area is going to be half of the apothem, which is 9 times the perimeter, which is 144 tangent 22.5. So the area is about 268.41, and the perimeter is 59.646. So she'll get that. She's got to write down the area thing, and then she'll write down how we found the angles, and then we're going to have the answers written down. All right, yeah. So she'll write that down then. Anyways, so then we're gonna flip it over after that, because that's the end of that page, and there's still a back page. So you have lots more fun in geometry land with me. So, anyways, yes. So, yep, just gonna fill the silence with my voice. Alright, so then she's gonna write down the answers. So I'm gonna move on to number 5 and start explaining that, and then you'll catch up once you see the picture, sort of. Well, it's just a circle with it inscribed. I believe it's maybe it's a 10, so that's like a decagon. So, so as you'll see once you flips over, it's going to be a decagon on the back. Yep, inscribed inside the circle. And we're going to find the area of the shaded region. So we're going to have to take the area of the circle minus the area of the dodecagon. So that's going to take a little bit of work. So, anyways, so I think we start off trying to find. Oh wait, no, we're going to start with the circle. So we're just going to find the area of the circle, and that's going to be pi times what am I saying? Oh yeah, it's gonna be pi r squared. That's gonna be 11.65 squared times pi, and that's gonna be the area of the circle, and it's gonna be minus what we find when we later find out what the area of the dodecagon is. So we find out that the interior or the angle on the inside is really 18 because we take 360 divided by 10 divided by 2, which is 18. So then we just use trigonometry and then we solve. So it's going to be 11.65 cosine 18 is going to be the apothem. X is going to be 11.65 sine 18. Inside one is going to be double x, which is 23.12 sine 18. And the perimeter is 10 times that, which is 231.2 sine 18. So then to find the thing, or to find the area, it's going to be 1/2 the perimeter times the apothem. So it's going to be 1/2 11.56 cosine 18 to 31.2 sine 18. And that's approximate value because we plug that in. It's be 392.734 or 9. I think. Oh, it's 9. And then the pi times the 11.56 squared, which is the area of the circle, is about 419.82. So we take 419.82 minus 392.739, and that's going to be about 27.083. So that would be the area of the shaded region. So that's our answer, and then we're going to write that in the appropriate place. All right. And so she's going to finish writing that down. So I'm going to move on once again to the next one so I can explain it more. Once again, we got to find the area of the shaded region in number 6. But this one's a little bit interesting because we're going to find the area of the sector, and then we're going to minus the area of the triangle in order to get the area of that little half circle ellipse thingy. So to find the area of the sector, we just use the sector formula. So it's going to be the angle, so the measure of the angle or whatever. So it's going to be the sector angle. So that's going to be 93 over 360 times pi times 7.5 squared, because 7.5 is the radius. That's going to be minus, when we figure out what all the other things are, like minus the area of the triangle. So we find out, so we divide it in half so we can get so that we can get right triangle, so that we can do keep on forgetting trigonometry. So then we're gonna x is gonna equal 7.5 sine 46.5, and the base is double that, which is because then you gotta double that because the x is half of the side of it, so it's base is gonna be 15 sine 46.5, and we find out the height to be 7.5 cosine 46.5. So then we just plug those values in or whatever. So it's gonna be half of that of the 15 sine and then the 7.5 sine. So it's gonna be the area of the sector minus that, and that's gonna have an approximate value of 17.5648. And then we write that down. All right. So then on to number 7, we gotta find the area of the shaded region, and for that we just we're gonna find the area of the circle and then we're gonna subtract the area of the triangle. So then we have so then we just divide up that equilateral triangle because we can't find it with just like the half thing, but we can. Then we just make like a right triangle out of the side thing to find out what half the side is, and then that's going to be special right triangle. So and it's going to have a side of 6, and then we know that 6 is opposite the 90-degree angle, so that's going to be 2x. on the, because you remember that, like, the sides are x, 2x, and the x squared root of 3. So then x is just going to be 3, and then the side that we want, which is going to be like the x, is going to be x, or it's going to be 3 square root of 3. So then the side is going to be double that, so it's going to be 6 square root of 3. So when we plug, so that's going to be one side of the equilateral triangle, so then we plug that into the equilateral triangle area formula, so it's going to be 1/4 times 6 square roots of 3, or squared, 6 square roots of 3 squared times square root of 3, and that's going to equal, once we get that all plugged into our calculator, the approximate value is going to be 66.332. Alright, and then we got to find the area of the shaded region in number 8, once again, and that's going to be like number 6, except it's just going to be doubled because we just got to, because there's going to be two sides to it. So it's going to be, so then they give us the thing to be, the sector area, or sector angle to be 92, so we're going to put 92 over 360 times pi times the radius, which is 5.4 squared. That's going to be, and then we're going to minus the triangles. And then after we do what we did basically in number 7 with the dropping to make it a, dropping the altitude or whatever to make it a right triangle, we're going to get the x to be equal like 2.7 or something. So then we're just going to double that, and then it's going to be 5.4, and then it's going to be cosine 46. And then the perimeter, or not the perimeter, half the, I'm not really sure. Anyways, so either way, so then it's gonna be 92 over 360 pi 5.4 squared minus half of 10.8 sine 46, and it's gonna be, anyways.